What we want to investigate in this project is if there is a difference between less and more degraded bays in terms of greenhouse gas emissions or greenhouse gas uptake. So we're measuring methane and N2O, CO2. And then we will switch between seawater and air to also be able to see how much methane, how much CO2 do we have in the air compared to the seawater, to be eventually able to calculate fluxes, so what comes out of the water.
Julika, now we have 18 here. Now we have a typical late winter, early spring situation. The ice has is gone. We have a little bit oversaturation of methane. So normally we have in the air about 2 parts per million, and now we measure here in the water 16 parts per million, which is 8 times oversaturated. In CO2 we have undersaturation because now you see also a strong insulation. And then we have a first phytoplankton bloom that develops here. So we have an uptake of CO2 by phytoplankton in the water column. And then we have N2O concentrations which are slightly, but only slightly oversaturated.
We're going to looking for what kind of microorganisms are living in the sediments, what is their role in this base. We are interested in figure out if you have more or less bacteria and archaeas that are producing methane. In what time, in what sediment layer, how this happen, what is the impact that these microorganisms have in these important gases.
These systems, if they are in a healthy condition, meaning that they have a high variety of key habitats, like for example seagrasses, that they are a carbon dioxide sink. And in this system here, which is heavily degraded by dredging and by eutrophication, they turn into anoxic, even in the sediments, and then a lot of methane is formed, and then they become a CO2 source.
This is going to get messy. The first one always gets messy. The idea now is that we just puncture holes at different depths. And then we withdraw some sediment with cut-off syringes. And then the sediment gets injected into this saline solution, which is supersaturated. And the general idea is that dissolved methane cannot dissolve anymore once it's in a supersaturated solution, so it evolves into a gas phase. And then it can be analyzed later on, that we would get like a nice depth gradient of how the methane looks like in the sediment. And based on the shape of this pore water profile, you can, for instance, predict how much methane will be released into the overlying water.
If they really manage to restore this kind of base in let's say, 10-year perspective, then we will have a chance to go back and do greenhouse gas measurements and then look whether these systems are still a source for CO2 or if they maybe have turned to a CO2 sink again.